I think the first thing to remember when looking at the Java API is that it's not a textbook. It's a reference book. So don't study it like you would study a textbook. Use it more like a dictionary or a thesaurus or an encyclopedia. You need to use it to look up pieces of information, not to feel like you have to know everything that is in it. I opened it up, I typed in Control F to find a particular class. I type in ArrayList and I scroll down here and I click on ArrayList. Now, sometimes we need to know what it implements. Let's look at the collection class. And how do I get to the class? I'm going to do a Control F. Collection. Now, it's hard to see, but there's collection, and it's in italics, meaning it's an interface. And there's collections, meaning it's a class. They're slightly different. We'll get to, the differences between a class and an interface more next semester. But if I have a method in the API, like sort, for example, and sort, sort for a collection actually expects something that is a list. Okay, so I've got a method. It expects something that is a list. Now let's go back to ArrayList. ArrayList implements the list interface. And so if it implements the list interface, we say that an ArrayList is a list. So if I look at any method that expects as input something that is a list, I can give it an ArrayList, because an ArrayList is a list. It implements the interface. A lot of these we won't go into detail, but I will show you examples of add, because we need to know how to add something to an array. And there are two variations of add. We can add elements, so that's what this big E is, because remember, when we create an array list, it has a particular type. So if it's an array list of integers, that E is integer. If it's an array list of strings, that E is a string. And so whenever we're looking at the API and we see that big E thing, okay, so this is a typed class. That E is the type that we use when we declare or initialize the variable. So we can add the object directly, and it's just going to append it to the end of the list. We can add it and pass it an int, basic data type, int, and the object. That int is an index telling us where in the list we want to add it. So we can add things in the middle. It's very important that we cannot leave empty spaces in an array list. So say the array list only has two things and we try to add something in index 5. Well, something bad is going to happen. Our program may crash all the elements. We can clone. This says shallow copy, and that's worth noting. What is a shallow copy versus a deep copy? Remember that objects are always held by reference. So this is an array list of integers. If I have some integer, say it's 5, that integer is an object in memory with the value of 5. If it's an array list of integers, and notice I'm saying integer, not int, then that integer is held by reference. Okay? So if I make a shallow copy, the new array list has all the addresses copied. So the new array list is going to point to that same object in memory. It's not a deep copy. A deep copy would be where it copies all of the objects in memory instead of just copying the addresses. And that's very different. So shallow versus deep copy. That we will later on in the course see examples of how the program behaves differently. Sometimes our output will be exactly the same with a shallow versus a deep copy, but sometimes it matters an awful lot. But just know that if you use the clone method of an array, it's going to create a new separate array, and it's going to copy all the addresses from one to the next. It's not doing a deep copy. It's not copying all the objects that it holds. Get, so we can call get and pass an index, and it'll return the element at that index. Index of, we pass it an object, and if that object is in the array list, it'll return the index or location where that object is. Index. It's possible to have an object in the array list twice. Say, what? How could you put something in there twice? Well, that one object exists in memory, and we might have two different locations in the array that hold the same address. Index of will return the index of the first occurrence, or the smallest index that points to that object. Remove removes the element from the list, and it returns the element that you removed. If you remove an object, if you pass it an object instead of a basic data type int, then it'll remove that object. Now, that object might be in the list and it might not be. If it is, it'll return true, saying, hey, yeah, I successfully removed that. But if it's not in the list, it'll return false, saying, oh, no, I didn't. Set is important. Set overwrites the value of an object. Size returns the number of elements in the list. So we've already seen add, and you're adding, oh, this is a little bit tricky. So I'm passing it a basic data type, and it's an array list of objects. Java does something that's called autoboxing. If the method expects an object, and you give it a basic data type, it will autobox or create the object for you. This add 12 is exactly like saying new integer 12. It creates the integer and then puts the integer object, and then puts it in the array. And we can see our array list has 12, 6, and 25 in the order that I put them. So let's say I want to set an index 1 to 13. So the 12 is at index 0, the 6 is at index 1, and the 25 is at index 2. So it will overwrite the 6 with 13. What else? My array list dot remove. Let's do a 6. Remove had two different types. One that expected an int, basic data type, and the other that expects an object. Now when I said add, there's only one kind of add. Well, there's only one kind with one parameter. There's another add with two parameters. We'll see that in a second. There's two kinds of remove with one parameter. One that tells me an index, int, and the other one that expects an object. So if I pass it an int, it's trying to use that 6, and it's trying to remove the thing at index 6. But I don't have anything in index 6. So it says array index out of bounds exception. So if I want to remove the 6, I have to say new integer 6. It's not going to auto box for me, because it thinks that I'm trying to call the method that expects an int basic data type. So now it removed the object because I eliminated the ambiguity by actually boxing it myself. Now I could pass it a valid index. If I wanted to remove the thing at index 1, it removed the 6 because the 6 was at index 1. If I try to remove the thing at index 2, it'll remove the 25. If I try to remove the thing at index 3, it's going to crash on me because there's nothing at index 3. Okay? There are 3 objects here at index 0, 1, and 2. There's nothing to remove at index 3. Now let's try to add at index 1 a 5. So it added the 5 at index 1, and it shifted everything else to the right. So it kind of inserts at the middle. Let's add it at index 12. That's going to be an index out of bounds. Because it can't leave empty spaces. So I've got something at index 0, something at index 1, something at index 2. What if I try to add it at index 3? This is okay, because it can do that without leaving empty spaces. So there's add, remove, and set. Let's look at size. I'm just going to say system.out.println myArrayList.size. It gives me a 3. So myArrayList.size tells me how many items are in the array list. Now you'll notice that the biggest valid index is always the size minus 1. That's something to be very careful about. Let's look at arrays real quick. If I want to initialize an array, I really have 2 options. One, this declares the array. This initializes it to an empty array of size 14. The other way is to do it all at once with the squiggly bracket notation. I can say int array. I'm going to call this one-liner equals. Inside of squiggly brackets, I can put 5, 6, 7, 8, 9, and then a semicolon. And that's going to work. It's going to put the 5 at index 0, the 6 at index 1, the 7 at index 2, the 8 at index 3, and the 9 at index 4. Now I can't just system.out.println my one-liner. Unfortunately, when I try to print an array, it actually prints the address, the memory address of where that thing is stored, not the contents of the array. So it's really nice and convenient to be able to print an array list. But what I can do is I can create an array list from an array. It's an array of basic data types. But I can't create an array list of basic data types. I typed integer, the object, in the hopes that I could convert it quickly. If I made the array of type integer, then Java is a little happier. About converting it to an array list. So this is a bit tricky. And all just so that I could print out the array. It's a little bit annoying that this is not nice. It's not a nice line of code. The other way to do it is something like with a for loop, which we need to cover anyway. For int I equals 0, I less than one-liner dot size. Oh, nope, dot length I++. System.out.print one-liner sub I plus space to make it look pretty. So what we can see here is my for loop goes through each element of the array, printing them out. Now I notice that I did a print, not a print line. Print doesn't go down to the next line. So it's going to print the first element, the 5, and then a space, and then the 6, and then the space, and then the 7 and a space, and an 8 and a space, and a 9 and a space. And then it doesn't even go down to the next line until it does this converting it to an array list and printing that out. So this is printing it out converted to an array list. This for loop would be much more efficient. The for loop works whether it's an int basic data type or an object. So I'm just going to comment that out. Notice how we access a particular element of an array. Square brackets and an index, an int. And we have seen that before in the last assignment, I hope. But that would be essentially the same as, say, my array list.get. So the array list at index 0 is holding the address of this object that's got a 12 in it. At index 1, it's got the address of the object that has a 6 in it. And at address 2, it has the object that has a 25 in it. To access them, we use the get method, get, and we pass it the index of the object that we want to get, and it returns the object. And so this will print out the object at index 2. And so the equivalent for an array is to use the square brackets in a 2, or square brackets in the index. Now for assigning a value in an array, we just put the square bracket thing to the left of an equal sign. We can say one-liner at index I is equal to, well, if I say a 5 here, it'll set all of the elements to the value of 5. If I want to set something in an array list, I can say my array list dot set, give it an int index, the index, and then the element value. I have two options with add. I have two options with get, but I only have one option with set. Set expects an index and a value, an index and an object. Remove, I have two options. I can remove the object at some index, or I can remove some object. Okay, so add, set, and remove. I can add the object and it'll append it. I can add the object at some index. I can set some object at some index and it'll replace the thing at the index. I can remove the object at some index and I can say int value is equal to, because this removes the item at index 1 and returns it. So I can then store it somewhere. Just like Java will autobox. So if there's no ambiguity, right, if there's only one possible interpretation, it'll autobox for you. If there's only one possible interpretation, it'll auto-unbox for you. So right now it's removing and returning an integer object. I can assign it to a variable of basic data type. It will unbox that object into a basic data type if there's no ambiguity. Index of. Now, the 25 object is at index 2. So this value index should get a 2. Okay, so if I don't remove any items, the 25 is at index 2. So some of these methods for array lists don't have equivalents in arrays. Okay? Because an array is fixed size, I cannot remove items, so there's nothing to do there. And I can't insert items, so I can't just add in the middle. There's no add. I just declare it as being of a particular size, and then I can either assign values to a particular index, or I can get the value at that index. So arrays, well, in a way they're a lot simpler. They're less complex than array lists. But it gets to be tricky to be able to use them effectively. It is convenient to be able to just create the thing and add stuff as we feel like.